Good evening, my dear students. This is Mrs. Suhair Zaki, and we are going to continue our journey in science curriculum for second prep students, second term. Let's start our session for today. We have finished the first lesson in our science curriculum. It was with the title Thermal Changes Accompanying the Physical Changes. And now we are going to start the second lesson in the first unit in our science curriculum with the title Thermal Changes Accompanying Chemical Changes. Our lesson objectives: deduce the law of conservation of energy, appreciate the role of scientist Helmholtz in discovering the law of conservation of energy. Also, by the end of our session today, you will be able to differentiate between exothermic and endothermic reactions. Mention examples of both exothermic and endothermic reactions. And you will be able to mention real-life applications of exothermic reactions. Explain the relation between chemical reactions and the law of conservation of energy. Let's start our session by a simple introduction. The figure here shows fizzy candy containing a mixture of sodium bicarbonate and citric acid. A lot of us and a lot of children like to show the fizzy candy from supermarkets. This is actually a kind of a mixture of sodium bicarbonate and citric acid. It gives a refreshing sensation when placed in the mouth, this fizzy candy. And in our lesson we will be able to explore ideas that will help you answer the following questions. In our lesson you will be able to find the answer of these questions. What causes this refreshing sensation from showing the fizzy candy? What type of reaction occurs when the candy is placed in the mouth? And what is the relationship between this reaction and the law of conservation of energy? You have learned in the first semester that when a chemical reaction occurs, the reactants are not destroyed but rearranged, and a new substance are not created from nothing but created from the rearrangement that takes place between the atoms of the reactants to give the new products. So, instead, the atoms of reactants are rearranged to form new products, keeping the number of atoms for each element unchanged, and that fulfills the law of conservation of matter. However, what about energy in chemical reactions that we are going to discuss and explore in our lesson today? To explore more about the energy and what happens during a chemical reaction, we are going to do a simple activity, and we are going to need some materials and tools. These materials are 2 lemons, 2 copper rods, 2 zinc rods, a connecting wire, and the lead bulb. And we are going to arrange the materials and tools as shown in this figure. Our step: we will start by inserting the copper rod and the zinc rod into each lemon. So, in each one of these 2 lemons, we will insert a copper rod and a zinc rod in the first lemon, and another copper rod and a zinc rod in the second lemon. Connect the zinc rod in the first lemon to the copper rod in the second lemon with a connecting wire. So we will connect the copper rod in first lemon to the zinc rod in the second lemon with a copper wire. So our first step, we will start to bring the two lemons and insert a copper rod and zinc rod in each one of them. The second step, we will connect the copper rod of the first lemon to the zinc rod of the second lemon with a connecting wire, like here in our figure. Our third step, connect the other copper and zinc rods to the lead bulb as here in the figure. So we will connect at the first the copper rod of the first lemon to the zinc rod of the second lemon. Then we will connect the zinc rod of the first lemon to the lead bulb, and we will connect the copper rod of the second lemon to the lead bulb. What we will observe, what will happen? The lead bulb lights up because the lemon acts as battery. By connecting two lemons in a row, like here, like a series, you will increase the voltage enough to power the light of the bulb. So what we will observe, the lead bulb lights up because the lemon here acts as battery. Based on the above, it's concluded that it's possible to convert the chemical energy stored in lemon juice into electrical energy, and of course fulfilling the law of conservation of energy. So energy cannot be created or destroyed, but it can be changed from one form to the other. Like here in our experiment, we changed the chemical energy stored in the lemon by we arrange a circuit with the copper rods and zinc rods and wires. We converted the chemical energy stored in the lemon juice into another form of energy, which is electric energy that used to light up the lead bulb as shown in our experiment. Now let's give a good recognition for this scientist, and we are going to get more information about Hermann von Helmholtz. This is one of the famous scientists. It's a German scientist who proved that energy neither destroyed nor created, but can be converted from one form to another, as we have shown in our previous experiment. We converted the chemical energy in the lemon into electric energy that used to light up the bulb. The total energy remains constant within an isolated system. So if we have an isolated system, the total energy remains constant, and this is known as the law of conservation of energy. So energy neither destroyed nor created, but can be converted from one form to another. Now we are going to discuss the chemical reactions and thermal changes takes place during the chemical reaction. Chemical reactions are usually accompanied by thermal changes, appearing as energy absorbed from or released to the surrounding. So chemical reactions are usually accompanied by absorbing energy or releasing energy to the surrounding, and we are going to explain more in the coming slides. At the first, we are going to explain the exothermic reactions, and to explain the exothermic reaction we are going to do an activity. In our activity we will need some materials and tools as usual. So what are these materials and tools? We are going to need dilute hydrochloric acid, magnesium ribbon, 2 nested polystyrene cups, laboratory thermometer, and we are going to arrange these materials as shown in figure 3. Our first step, place 50 milliliters of dilute hydrochloric acid in the nested polystyrene cups as shown in figure 3. Our second step, record the initial temperature T1 using the thermometer. So this is our second step. We are going to record the initial temperature T1 by using the thermometer. Step number 3. Immerse the magnesium ribbon in the acid while stirring gently with the thermometer. This will start our chemical reaction between the magnesium ribbon and the dilute hydrochloric acid, and we are going to detect the change in the temperature of our chemical reaction. The next step, step number 4, after reacting of magnesium ribbon with dilute hydrochloric acid, record the final temperature T2 reached by the reaction mixture. Which is greater according to your recorded temperatures and your observation? Is it T1, the initial temperature, or T2, the final temperature after completing the chemical reaction between the magnesium ribbon and the dilute hydrochloric acid? Let's explain what happened during our experiment. The reaction of magnesium with dilute hydrochloric acid is accompanied by the release of thermal energy, leading to an increase in the temperature of the system, which is the reaction mixture. And that is why we will observe that the final temperature T2 is higher than the initial temperature T1. In our experiment, we find that the thermal energy is released and increase the temperature of the final temperature than that of the initial temperature according to the reading of the thermometer. Its turn leads to an increase in the temperature of the surrounding. This is our system where heat transfers from the system to the surrounding. In this case, the reaction is an exothermic reaction. What are the surrounding in this reaction? The surrounding are the thermometer, the beaker in which the reaction takes place, and of course the surrounding air. And this system in this case is an open system, not an isolated system. This reaction is described as exothermic reaction and is expressed by the following thermochemical equation. Magnesium, Mg, which exists in a solid state, so we will write S between brackets, plus hydrochloric acid, HCl, which exists in an aqueous form, so we will write AQ between brackets, gives magnesium chloride, MgCl2, which is also aqueous as the salt is dissolved in the water, plus hydrogen gas that is evolved during the chemical reaction, so it's in its gaseous state, so we write G between brackets, plus heat that is released and causes the increase in the temperature of the thermometer at the end of the reaction, as we discussed before. So based on the above, it's concluded that exothermic reactions are reactions that release thermal energy to the surrounding medium as a product, causing the temperature of surrounding to rise. And as we explained, the surrounding includes thermometer, the beaker, the surrounding air, where the system is the reactants inside the container in which the chemical reaction takes place. What are the examples of exothermic reaction? Here are some examples. Reaction of metals with dilute acids. Reaction of alkalis with acids, which is called neutralization reaction. And reaction of metal carbonates with dilute acids. So all of these. Now we are going to have this wonderful topic, integration with life science, biology. Luminous insects like fireflies, like here in our figure, emit light from the abdominal area, this area, as a result of exothermic chemical reactions occurring inside their bodies. In these reactions, most of the resulting energy is converted into light, not heat. It's converted into light. These insects control the timing and duration of the light they use for various purposes like mating and self-defense. So this is one of the wonderful phenomena in some insects in which this reaction takes place. Most of the resulting energy converted into light, and the insects control the timing and duration of the light produced for different reasons like mating and self-defense in some cases. Now we are going to learn about the life applications depending on the thermal changes accompanying the chemical changes. The first application is the self-heating cans. In our first application, these cans contain an inner cone holding calcium oxide, which is called quicklime, and water separated by a thin membrane. This can includes two chambers. The inner chamber contains the food or beverage. The outer bottom chamber contains two separate chemicals, which are calcium oxide and water. This is the structure of this self-heating can. What will happen if we want to heat up the food inside the can? When the bottom at the can is pressed, the membrane ruptures and an exothermic chemical reaction occurs, forming calcium hydroxide solution, which is the lime water. So when we activate the can by pushing a button on the bottom of the can, a seal breaks between the water and calcium oxide. So they mix together, the water and calcium oxide. Reaction takes place and forming the calcium hydroxide. During this reaction, the heat is released, and of course this is an exothermic reaction. So heat is released as an amount of thermal energy. The heat travels through the metal walls of the inner chamber, warming the food in about 3 to 5 minutes. The reaction that takes place inside the self-heating can is the calcium oxide, which exists in a solid state, plus water, which is liquid, gives calcium hydroxide, which is the lime water, plus an suitable amount of thermal energy that heats up the food inside the can. Calcium hydroxide powder is known as slaked lime. Don't forget this information. Our second life applications, the thermite reactions. The reaction of aluminum with red iron oxide is accompanied by the release of a large amount of thermal energy, leading to the melting of iron produced from the reaction. In the thermite reaction, and accordingly, the reaction is used in welding railway tracks. Like here in the figure, we can observe the worker use this reaction, and the high thermal energy results from the thermite reaction to weld the railway track. In our reaction, the aluminum is added to iron oxide, and the resulting is aluminum oxide plus iron, which will exist in its liquid state due to the very high thermal energy results from this reaction. Now let's examine our understanding and try to solve this question. Choose the correct answer. The dissolution of which of the following substance in water leads to a chemical change accompanied by the release of thermal energy? Sodium hydroxide, calcium oxide, calcium carbonate, sodium chloride. Of course, our choice will be calcium oxide, and that is used in our self-heating canes, in which we react the calcium oxide with water to give the thermal energy needed to heat up the food inside the can. Choose the correct answer. The following table shows initial temperature T1 and final temperature T2 for 4 chemical reactions with the same amount of reactants. So this is our table, and the question is, which of these reactions has released the greatest amount of thermal energy? Reaction 1, reaction 2, reaction 3, or reaction 4. We will need to calculate the difference between T1 and T2 to choose the reaction with the high thermal energy released, with the greatest amount of thermal energy released. So the first reaction, T1 is 22, T2 is 17. In this reaction, thermal energy is not released but absorbed, so this is a wrong one. The second reaction is one of the exothermic reactions because temperature T2 is higher than T1. So what is the difference between them? The difference is 4 degrees Celsius here in reaction 2. For reaction 3, the reaction also is exothermic, where the thermal energy is released as the temperature T2 is higher than T1, and we calculate the difference between the two of them. So 27 minus 20 equals 7 degrees Celsius. The fourth reaction, where the T1, the initial temperature is 20, the final temperature is 18. We observe here that the temperature at the end of the reaction is less, so the thermal energy in the fourth reaction is absorbed, not released, so it's an endothermic reaction. So we will choose between reaction 2 and reaction 3. Both of them, the thermal energy is released. But what is our choice? Our choice will be according to the highest difference between T2 and T1. We calculated the difference in reaction 3, 7 degrees Celsius, while reaction 2 is only 4. So our choice will be 3. So the reaction 3 is the reaction that has released the greatest amount of thermal energy in this table. This was our last question in our session for today. Me, Mrs. Suhair Zaki, was with you today on the Ministry of Education live stream under the consultation of the Science Consultant Office of Ministry of Education. See you next session, inshallah.